So I'm going to show you a quick hotbox test. These are the little hotboxes that we made up that show the Infinite R phase change material in action. What we have in here is a 78-degree phase change material, and we're showing it with two chambers side by side. We have some lights in here, and the light creates heat so that we can try to melt the phase change material or simulate basically a high heat environment and try to compare with and without phase change material. So what we have is a layer of drywall, gypsum board, and the Infinite R on this side is a 78-degree phase change material, so it wants to melt at around 78 degrees. And then we have here some fiberglass insulation on the underside of each one. We have a sensor on the underside of our phase change material and a sensor on this side with temperature readings to show what the difference is. So you could think of this like the inside of a wall. You could think of this on the top of a roof system where the Infinite R is right on the outer boundary. When we've got a little layer of insulation above the Infinite R, it obviously helps. So the reason we set it up this way is that we can show dramatic results in a very short period of time, so we can try to melt the phase change material as quickly as possible so that you can see the reaction. It's a really nice cold day out here in the Northeast. It's roughly mid 20s outside Fahrenheit, so it's below freezing point. So what I'm going to do is show the hotbox as we're heating it up, and then I'll unplug it, and then we'll be able to see it in time lapse on the cooling side as it begins to cool down, and you can see the difference from one side to the other. So let's get going. So as I turn the lights on, you'll see immediately on the left-hand side there's a rapid increase in temperature. That's the side without the phase change materials. And on the right-hand side, there's a much slower progression of increase. And that's because there's already thermal mass that we're adding to that side of the assembly. And you can think of it like an ice pack on that side that as it gets closer to its melting temperature, which is 78 degrees, it begins to melt and absorb heat, staying around that 78-degree range. So it's fighting to keep that side at 78 degrees until it's completely melted. And so as we switch the heat off and allow things to cool back down again, you'll once again see a rapid decrease in temperature. While on the right side with the phase change material, it continues to just sort of hang around that 78, 79 degree range for quite some time before it will eventually refreeze, and as it's refreezing, it is releasing the heat that it absorbed on the previous cycles. So in winter, that means releasing that heat into the space for maintaining overnight temperatures, and then in the summer it means using those overnight cool temperatures to refreeze the phase change material for another day of air conditioning savings. Now you can use Infinite R phase change materials in ceiling applications on suspended tiles and grid. You can put it inside of wall systems to absorb internal heat or reduce heat gain through walls in hot climates on the exterior. You can put it in attic systems, either above or below the insulation. And a great place to put Infinite R is in a roofing system, flat or pitched roofs. Cuts down on heat flux and dramatically reduces heating and cooling costs.